In the previous lecture, we studied the sampling distribution of sample variances. We can use that distribution to estimate population variance. Let's look at the example. Here's some example why we estimate population variance. Two companies supply bolt to an automaker. Bolts are defective even if they are too large or too small in diameter. The automaker wants to recognize the variance of bolt diameter supplied by each bolt company. Use them as data for decision making. You know why we are studying variance? This is one example. Variance is closely related with the quality of a certain product. In this case, some bolt. Here's another example. To evaluate the difficulty of the college entrance exam, the variance of the exam score is calculated compared with the variance of previous year. I mean, the variance measure can be used how difficult a exam is. How can you do that? Based on sampling distribution theory, we discussed that sample variance is a good estimator for population variance. Actually, it is an unbiased estimator. I mean, the mean of all possible sample variances become population variance. Well, similarly, point estimation of the population standard deviation is a sample standard deviation, but it's not unbiased estimator. In case of sample variance, do you remember that when we calculate the sample variance, we divide by n-1. The reason we divided by n-1 is to make S square sample variance become an unbiased estimator. How about the interval estimation? I cannot teach in detail, but we can derive that. Suppose we have sample variance, the population, the confidence interval can be calculated in this manner. What is this notation? Depending on sample size, we are using chi-square n-1, the distribution, and then we are looking, in case of 95%, we are looking 2.5% each. Therefore, well, total it would be 95%. But why we are using the different value? Because chi-square is a skewed distribution. It's not normal or t, they are symmetric. Therefore, you have to find this value. In case of 95%, you are looking for left tail 2.5%, right tail 2.5%. The standard deviation confidence interval, you are just take a square root. Here's the example. Here's a college student as a sample standard deviation is 5. Point estimation is estimation of variance would be sample variance. It is 5 square 25. For the standard deviation is like this. 95% confidence interval. Since the sample size is 25, we have to look up chi-square 24 distribution and looking for right tail 2.5%, left tail 2.5%. Well, just plug in number, you will have this one. In case of standard deviation, we just take a square root. How about this example? Suppose you have a real data, E-stat has a good module to calculate confidence interval. Let's look at that. Let's copy this number. Let's go to E-stat U and then estimation for variance. Okay. Then copy the data here. Well, they automatically calculate the sample size and sample variance. Well, they already calculate confidence interval depending on confidence level. Well, they show you the confidence interval. You can experiment what is the change of this confidence interval. What is the change depending on 1 minus alpha. For practical application, I think ESTEL would be helpful. Okay, this is the topic today.